Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Mind Maps, we're going to be looking at metals and non-metals. This is the third chapter in the science textbook for grade 10 of CBSE. And this chapter comes under the section of chemistry, and in this chapter we're going to be looking at the 92 natural elements that we find, and we classify them into metals and nonmetals, and we look at some of their properties in detail. So, in order to study this chapter, we have enlisted the help of this mind map. Mind maps are pretty useful at last-minute preparation for your exams. However, they can be quite extensive. That's why this video is devoted to explaining this mind map in some detail. So, metals and nonmetals. The natural world is comprised of about 92 elements. The other elements in the periodic table are artificial. And the natural elements are broadly divided into metals and nonmetals. Now, metals are elements that donate electrons to other elements in order to form an octet, which is an outer shell of 8 electrons. In the case of nonmetals, they accept electrons to form an octet. So that means they have, a scarcity of electrons which they want to fill up with other electrons. And in the case of metals, metals have an excess of electrons in their outer shell, so they want to remove some of them in order to be stable. So, these elements, metals and nonmetals, both are derived from natural minerals, which are combinations of these elements. And there are some minerals which have a high concentration, which are called ores, and they are cleaned by various processes, and that depends on the type of metal or nonmetal we have. And both metals and nonmetals have characteristic physical as well as chemical properties, and we're going to discuss those in this chapter. So we'll be discussing metals, their physical and chemical properties, nonmetals, their physical and chemical properties, ores, how do you clean ores for highly reactive metals, medium reactive metals, low reactive metals. So, metals. These are the elements which donate electrons because they have an excess of electrons which makes them unstable. So, how do you recognize a metal physically? Well, let's look at their physical properties. Number one, they are solids. Most of the metals exist in a solid state. However, mercury, or Hg, is an exception, because mercury, as you see in thermometers, exists in the liquid state. It's in fact the only liquid metal there is. Now, another physical property of metals is that they have high MP and BP. MP stands for melting point, BP stands for boiling point. So it's very difficult to melt or boil metals. You have to heat them at astronomically high values of temperature. The exception for these are once again mercury and also other metals such as gallium. The metal gallium melts at about 30 to 35 degrees Celsius. So if you were to place a piece of gallium in your hand, it would melt right before your eyes. And mercury also has a very low melting point. That's why it's liquid at room temperature. Now, another characteristic of metals is that they're very dense. High density is found in metals. Some exceptions include sodium and potassium, which are relatively less dense metals. They do float on water. Malleable metals are also malleable and ductile. Malleable means they can be beaten into sheets, and ductile means they can be strung into thin wires. So metals have the unique ability to be beaten into sheets and strung into wires. Metals such as gold and silver are exceptional at their malleability and ductility. And metals are very good conductors of heat and electricity. This applies to every metal. In addition, metals are usually hard. However, sodium is an exception due to the fact that you can cut it with a knife. So it's as soft, it's so soft that you can cut it with a knife. There are other metals which are similar to sodium, which are very soft. Now that we've looked at physical properties of metals, let's look at some chemical properties. How do metals behave chemically? Well, when you react metals with oxygen, you form metal oxides. An example for this is the formation of sodium oxide. 4Na plus O2 gives you 2Na2O. If you look the case of magnesium, 2Mg plus O2 gives you 2MgO. So metals, they form metal oxides when reacted with oxygen, and most of these metal oxides are basic. The exceptions are aluminium and zinc, which are amphoteric. Now, the word amphoteric means they are both basic and acidic. So basically, if an amphoteric oxide reacts with a base, it will act as an acid, and if an amphoteric oxide reacts with an acid, it acts as a base. So therefore, aluminium and zinc are exceptions to the mostly basic rule. So metal oxides are usually basic in nature, except for aluminium and zinc, which are amphoteric. Now, what happens if you react metal in water? Metal plus H2O gives you metal hydroxide. An example for this is the hydroxide of aluminum. 2Al plus 6H2O would give you 2AlOH thrice plus 3H2. So as you can see, aluminium forms an oxide, hydroxide, and you have an excess of hydrogen that is released. Now, what happens if you react metal with acids? When you react metals with acids, you get salts along with the evolution of H2 gas. For example, Mg plus 2HCl, this is hydrochloric acid, it gives you MgCl2 and H2. So hydrogen gas is released. So when you react a metal with a dilute acid, you will get salts along with H2. Metals also react with chlorides in order to form metal chlorides. Example, again, you can use Mg plus Cl2 to form MgCl2. You can also use the hydrochloric acid route in order to form magnesium chloride, but you can also just add chlorine to magnesium in order to get magnesium chloride. And finally, you have metal reacting with H2 to form metal hydrides. These are present in elements such as lithium, aluminum, sodium, boron, etc. So there are some metals which do form hydrides, but others don't. Now that we've looked at the physical and chemical properties of metals, let's look at the other end of the spectrum, nonmetals. How do you recognize nonmetals physically? Well, for one thing, they have varying states. Nonmetals can be solids, like for example carbon, sulfur, etc. They can be gases, such as the noble gases neon, argon, krypton. Or they can be liquids, such as bromine. Bromine is the only nonmetal which is liquid. Now, nonmetals are usually consisting of lower melting and boiling points. So their melting and boiling points are lower than metals, but they vary they vary highly. So some nonmetals have a very low melting point so that they exist as gas, or but there are others such as sulfur or carbon which have appreciably high melting points, which makes them solid at room temperature. Now, what about the brittleness of nonmetals? Nonmetals are very brittle, so that means they break easily when you apply force on them. So that also means that they are non-malleable and non-ductile. So basically that means if you try to press them into a sheet or pull them into a wire, they just break off. They don't turn into wires or sheets. And that's called brittleness. So they're non-malleable. You can't make them to sheets. They're non-ductile. You can't string them to wires. And they are poor conductors of heat and electricity. This is a general property. There are exceptions, and the exception here is graphite. Now, what is graphite? Graphite is an allotrope of carbon. It's basically a different form of carbon, and this form of carbon does conduct electricity as well as heat. Also, metals are usually very shiny when they're pure. However, nonmetals aren't shiny, which means that they are non-lustrous. However, there are exceptions to this, such as iodine and graphite. Iodine is pretty shiny, graphite is also lustrous. And nonmetals are usually quite soft. The exception here is diamond, which is the hardest substance on Earth. So, we've looked at nonmetals and their physical properties, but what about chemical properties? How do they react with metals and other reactants? If you were to, if you were to react nonmetals with oxygen, they do form nonmetal oxides. These oxides are usually acidic or neutral, and an example for this is the formation of sulfur dioxide. S plus O2 gives you SO2. Now, nonmetals, along with steam, they release H2. So some nonmetals turn into their hydroxides. However, others, which are less reactive, they turn into their oxides. Nonmetals do not react with acids because they are themselves acidic, so there is no reaction when you combine nonmetals with acids. However, nonmetals do react with chlorine in order to form nonmetal chlorides. And an example for an example for this is BrCl2, bromine chloride. And there are other reactions as well. Since nonmetal oxides are acidic, you can use them to form acids, and you can also react them with metals in order to form salts. So therefore, this is an overview of the chemical properties of nonmetals. Now, metals and nonmetals are usually found in a combined state in nature, and the combined state of metals and nonmetals are usually called minerals, which are found in rocks. And when these minerals have a high amount of a single metal or a single element, then they're called ores. So ores are minerals with usually high concentrations of one element, and also they are easy to be extracted. So that means you need two conditions to classify a mineral as an ore. Number one, it should have a high concentration of a single element, and number two, you must be able to extract the metal from the ore in an economic way. There are some minerals which contain, you know, metals, but then they are either in very few concentrations, or they are extremely difficult to extract. So in those situations, these are called minerals and they're not called ores. And ores are usually the sources of metals, so they are purified to get metals or nonmetals. So there are three broad steps in purification of ores. So number one is concentration. So we, with variety of processes, we concentrate the ores so that there's more amount of ore than just bare rock. So when we find ores, there are a lot of rock, sand in between them. So we concentrate the ore first so that we can remove extra. We can, concentrate them so that we can extract more of the metal out of it. Next, we remove impurities from the ores. So even after you remove the rocks and sand, etc., there still are some chemical impurities present in the ore. So then you have to remove those impurities by using processes such as froth flotation, magnetic separation, etc. Now, these processes you'll study in grade 12 in chapter 6. But let's move on to the next step. The next step is dependent on how do we extract the metal. It depends on the reactivity series of the metal. So this is the reactivity series. As you can see, there are some metals such as sodium, potassium, calcium, etc., which are highly reactive. They even react with oxygen in the air and blow up. So these metals are part of the high reactivity group. Metals such as zinc, iron, lead, and copper are usually found in the medium reactivity group. And, rare metals such as gold and silver, or even platinum, are found in the low reactivity group. So, how do we extract the metal from its ore? Now, when it comes to low reactivity, these metals, such as gold and silver, are usually found in their native state, or they are found in their sulfide ores. And when you have sulfide ores of these, metals, you first burn them with excess of air. This is called roasting. And after roasting, you get metal oxide, so after roasting, you get metal oxides, and these metal oxides are reduced by carbon, and then they are refined to get the pure metal, such as gold and silver. Now, on the other end of the spectrum, we have metals which are highly reactive. So that means you can't use, substances such as carbon to reduce them. The only way to extract them is to use electrolysis. So first we melt the ore, and then after melting the ore, we use electrolysis in order to separate the pure metal from the impurities. Now, when it comes to metals of medium reactivity, such as zinc, iron, lead, etc., you have two processes, and these depend on the type of ore we're talking about. Now, let's take zinc. Zinc exists as carbonate ores, such as ZnCO3, or it exists as sulfide ores, such as ZnS. So if you have ZnCO3, we use a process called calcination. Now, in calcination, the ore is heated with less air. So there is very little air present in the chamber for calcination, and that gives us the metal oxide. When you look at the sulfide ores, these are heated in excess of air. So that means they have a lot of air present in that chamber. So after roasting, you get both of them, you get metal oxide. So once you get the oxides, you then make sure that they are purified using specialized processes, which again you will learn in higher lessons. Now, that concludes the mind map for this chapter, but again, it's not just mind maps that help you revise these chapters. Introducing flowcharts. So let's look at a flowchart for the chapter as well. So elements, they are divided into metals and nonmetals. Physical properties of metals, they're solids, they have high melting points and boiling points, high density, malleable and ductile, good conductors of heat and electricity. Nonmetals, they're found in solid, liquid, and gaseous form. They have low melting and boiling points, not malleable and ductile, poor conductors of heat and electricity. Now, when we look at chemical properties, metal plus O2 gives you metal oxide, metal plus H2O gives you metal hydroxide, metal plus dilute acid gives you salt and H2, metal plus Cl2 gives you metal chloride, metal plus H2 gives you metal hydride. Non-metal plus O2 gives you non-metal oxide, non-metal plus steam releases H2, non-metal plus acid means no reaction, non-metal plus chloride gives you non-metal chlorides. So these are both the physical properties and the chemical reactions for both metals and non-metals. When we look at extraction of metals, the first thing you do is concentration or enrichment of the ore. So the impurities in an ore are called gangue, and they are mixed with substances called flux in order to remove them, which are called slag. And then we separate the impurities. The separation depends on the difference in the physical or chemical properties of ore and the gangue. So depending on both the ore and the gangue, we have various types of separation techniques, which we will study in higher lectures, higher grades. Now, for metals of high reactivity, such as sodium, potassium, magnesium, and aluminum, the best way to purify them is by electrolysis. So you melt the ore and then you extract the pure metal using electrolysis. Now, for metals of low reactivity, you either find them in their native state or you find them as their sulfide ores. So first you roast the sulfide ores, which means heat them in the presence of air, until you receive metal oxide. So when you get metal oxides, you reduce them with carbon, and then you refine those metals once more to get pure metals, such as gold and silver. Now, for metals of medium reactivity, we have two cases. The first case is when you have a carbonate ore, such as ZnCO3, and the other case is when you have a sulfide ore, such as ZnS. With carbonate ores, you have to heat them in the absence of air. This is called calcination to form metal oxides. Sulfide ores are roasted. That means they're heated in the presence of air to get metal oxides. So the thing is, you have to convert the ores to their oxides, and from oxides you can reduce them using any number of reduction techniques, such as reducing using carbon, aluminum, etc. And then you finally purify the metal so that you get the pure metals. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. We have a lot of content here based on mind maps as well as other flowcharts. So if you want to access those, you can hit the link of the playlist in the description box below. And also, if you want to get our latest updates, then don't forget to hit the notifications icon present below the video. So, until the next episode, take care, stay safe, bye-bye for now.